this back up here. And for the benefit of those online, on the tablet here, on 6.6, we went to the bottom of the page before class started and worked. It looks like we worked some problems here. From 6.5, number 15, and from, what, 6.4, number 69 and 67. And for 6.6, stop when you get to 47. Let's scroll back to the top and start working these problems. What was that all about? I don't know. If they're programming these things with artificial intelligence, I'm here to tell you that artificial intelligence isn't very smart. It just keeps messing with me. So I'm not very happy about AI. Page 390. Everybody understands that we're doing, this is the last topic in the chapter. So that means on Wednesday we do the practice test, and you come in on Friday and take the exam. And we're basically finished with this course. And, oh, and if you want to correct your test, then you can come back on Monday at 8 o'clock to this same place, and I'll give you your test back so you can fix the problems you missed. Yes?
What if we're not going to be here?
Maybe you'll just take the grade you get on the test?
Okay. Because I think that a lot of people have to be moved out by Sunday.
They do?
Everyone in the dorms has to be out by Sunday.
What's that all about? Well, then should we schedule another time for Friday to come back and correct your test?
Yeah.
What about like over lunch?
Over lunch. Yeah, why couldn't we do that? Okay, will that work for everybody? If you want to correct your test?
Unless people have a class right after lunch.
Oh.
You could email us a scan of the test and we could make corrections to that and email it back to you.
You could see if anyone wants to just take their grade and those who don't, just like correct them quick as we turn them in.
Isn't that something? You have to be moved out by when?
Sunday.
At 8 a.m.
So, what if I come in here on Saturday?
I'm leaving on Friday.
What?
I'm leaving on Friday, but that would probably work for everyone else.
So when on Friday could you do it?
I am free all day Friday.
So you could do it at lunch?
I could do it at lunch.
Could everybody do it at lunch?
So some people have.
Have a class at lunch?
If it starts at 12, it should be okay. Classes are at 12:30.
Lunch goes from what? 12 to 12:30?
12:45.
12:45.
But there are classes at 12:30.
Oh, there are?
Yeah.
I don't have one.
So, who has a class at 12:30? 1, 2, 3. So, what are you doing after your 12:30 class?
Going to work.
What?
Going to work.
Oh, man.
Where do you work at?
No.
Wow.
maybe after lunch.
Okay. The people who have a class after lunch, I'll be here at what goes on in chapel on Friday? Is it baccalaureate?
Yeah.
So after baccalaureate, I'll come directly in here and have your math test graded somehow. Okay? And then for those who have a class at 12:30, come and see me and I'll make individual arrangements for how you can correct your test. Will that be okay? Because I think there were like 3 of you. Okay. Well, let's see if we can get this last topic down, because you have to know this for the test. This ratio stuff. On problem 2, page 390, during the last 6 years of his life, Van Gogh produced 700 drawings. So 700 drawings and what? 800 oil paintings. Write the ratio of drawings to oil paintings in 3 different ways. So here's one way, 700 to 800. Here's another way, 700 ... 800. And here's the third way, 700 over 800, a fraction. Or 7 to 8, 7 ... 8, and 7 over 8. Because you can reduce the fraction down. 700 over 800 is the same as 7 to 8. So the ratio is 7 to 8. For every 7 drawings, he had 8 oil paintings. You follow the way you're talking about ratio. Number 6. Most job seekers can expect about 6 job leads for every 100 resumes. So 6 interviews for every 100 resumes. What's the ratio of job leads to interviews? The ratio, 6 to 100, or 6 ... 100, or 6 over 100. And that would be the same as 3 to 50, 3 ... 50, or 3 over 50. Just reducing the fraction down. Number 8. Are generic products always cheaper than name brand? Not necessarily. It depends on where you buy the product. When comparing 2 cans of mushrooms, the name brand 8-ounce can is $1.09, so name brand 8-ounce is $1.09. The generic brand 4-ounce is $0.53. To the nearest 1/10 of a cent, what's the cost per ounce of the name brand? So they want cost per ounce of the name brand. Well, if it's $1.09 for 8 ounces, then what would it be for 1 ounce? Or $1.09 to 8 equals what to 1? And can you see where you would just divide this by 8, divide this by 8, and you would get your number? I guess I should have got my calculator out here so we can do some of this stuff. So 1.09 divided by 8 is 0.13625. And what did they say? 1 to 1 for 1 ounce. And they said to the nearest what? 1/10 of a cent. So I take it out this far, so it would be 13.6 cents. B, cost per ounce of generic brand, 53 to 4, divide both by 4, and you end up with 53.53 divided by 4 is 0.1325, or 13.3 cents. Because you take it to the nearest tenth, you look at the 5, you change that to a 3. So here's 13.6, here's 13.3 per ounce. Is that all they want us to do? Which can is a better buy? Well, this one is cheaper, but have you ever tasted the difference between mushrooms made by Price Chopper and mushrooms made by another company? I'm thinking I'm buying the name brand for that much difference in price, because Price Chopper's mushrooms taste funny. Personally. So, which is the better buy? Oh, that also depends on the contents. Which one has more mushrooms in it and which one has more water? You've probably never opened a can of mushrooms or green beans and poured out the water and counted how many beans were in there just to see which one's the better buy. Only people like me who have too much time on their hands do things like that. I just like to know what's going on. In example 2, the 4-ounce can cost, that's from back on page 384. Example 2 is from 384. It said a 4-ounce can cost 18.5 cents an ounce. Which is the better buy? 1 ounce at 18.5 or 1 ounce at 13? You know, I'm thinking if it's the difference between 13 cents an ounce and 18 cents an ounce, 5 cents an ounce is almost half, again, as much. Maybe I'll buy the cheaper mushrooms and put some sauce on them to make them taste better. I'm pretty cheap. Number 10, if you haven't figured that out yet. Is cheaper still better? Here's another problem. A&P wool washing liquid costs 79 cents for 16 ounces, and ivory liquid is $1.25 for 22 ounces. So, A, to the nearest cent, what's the price per ounce of the A&P? Well, what was it? 79 cents to 16 would be what? To 1. You divide 79 and you get 0.049375. So the price per ounce is 4, did they say to the nearest cent? To the nearest cent. So the price per ounce to the nearest cent would be, look at the 9, 5 cents per ounce. For ivory, it would be 125, 1.25 divided by 22. That would be 0.056818. So to the nearest cent would be 6 cents. So this one's 5 cents an ounce and this one's 6 cents an ounce. I'm thinking, I never was much for A&P stuff, but I love ivory. So I'm thinking I'm just going to pay an extra penny an ounce and buy ivory. Oh, but wait a minute. How much do you have to use? According to Consumer Report, it costs 17 cents. For A and P, and 12 cents for ivory. Oh, even though I'm paying more for the ivory, it doesn't take as, you know, it says put one capful in the washing machine. Well, the capfuls are different sizes, and it's 12 cents to wash a load with ivory and 17 cents to wash a load with A and P. That means the cap's bigger and it takes more of it. You follow what's going on? Ah, they're messing with me. Ivory's a little more concentrated. So I made a better choice buying the ivory. Now, when I read this problem, did you have the same? Oh, you haven't read them yet. But when I read this problem, see, it said 17 cents for 10 washes. Does that mean 17 cents? See, from what it sounds like, it says that's 1.7 cents per wash. That doesn't make any sense. Because I went to the internet and I Googled how much it costs to wash stuff using all this detergent. And Arm & Hammer, there's a whole list of them there. You don't even care, but I'm going to show you anyway. Arm & Hammer, $33 for a 280 load container. That's 12 cents a load. So I'm thinking that somehow the book doesn't have the right information. Gain is $22 for a big old thing that'll do 150 loads, and that's 15 cents. Tide, $12 for a bottle that does 69, or a box powder, that's 19 cents a load. But look at this. Woolite is 34 cents a load. Well, unless you get the fancy Woolite, and it's $3.20 a load. And the high-powered Tide is $2.37 a load. You better check this stuff out before you just pick up that good-looking bottle. They might be charging you way too much to do your laundry. You don't care. Number 12. 11 through 16, solve each proportion. Okay, when they say proportion, there it is. X over 6 equals 5 over 12. Were you taught this somewhere? That the product of the means equals the product of the extremes. Or the product of the means equals the product of the extremes. And that's like saying X to 6 equals 5 to 12. And then this product here equals this product here. So that means 12x equals 30. So x would equal what? 2 12s is 24, 2.5. Number 14, 6 over x. So you multiply 6 times 7, x times 18. 18x is 42. So let's take 42 and divide by 18. And we get x is 2.333 ... which would be 2 1/3. Do we all know that? Hopefully. 16, 3 times x equals 5 times 9. So x equals 15. Everybody follow what's going on? Number 18. I don't know who's writing these problems. I mean, it's hard enough learning to do story problems without them messing with your head. Look what 18 says. A woman has several rectangular flower beds that she wants to be of equal area. Okay, if I want the areas to be equal, then that means 3 times L. The area here is 3L. and the area here is 20. So if I want these areas to be equal, 3L would have to equal 20, which means L would have to be 6 2/3. You follow me? But that's not the way the problem works, and that's not what the answer key says. It says if L is the length of the bed that's 3 feet wide, so let's change to blue, and the length is 10 feet for the one that's 2 feet wide, write a proportion using the ratio of L to 10. So what I have is L over 3 equals 10 over 2. You see where I get that? But do you also understand that I could also say that's the same as L to 10 equals 3 to 2. You say, how can you say that? Watch. L to 10, see, L to 10 would equal 3 to 2. Yet you can use the numbers in more than one way. It's just you have to be consistent. If I take L and 10, then I have to take 3 and 2. If I do L over 3, then I have to do 10 over 2. And no matter which way you set it up, but since they said use L and 10, I use L to 10 equals 3 to 2. And what happens? Cross multiply here. 2L equals 30, so L is 15. And that's the keyed answer. So I don't know why they put that word equal in there. Number 20, when serving shrimp, you need 1/2 pound for 3 servings. So how many pounds do you need for 90 servings? What do you take times 3 to get 90? Times 30. So let's take 1/2 times 30, and what do you get? 15 pounds. Or you could set up 0.5 to 3 is something to 90. Multiply the outside, multiply the inside, and you still get the same answer. Or you could do 1/2 over 3 equals something over 90, and you still get the same answer. You need, when it comes to this proportion stuff, you need to pick a method that you feel comfortable with and then use that method. Number 22. It says Tom can eat 74 tortillas in 30 minutes. At this rate, how many could he eat in 45 minutes? Well, 74 over 30 would equal something over 45. Or 74 over something would equal 30 over 45. They'll both work. And either way, what do we come up with? 30 times something equals, what's 74 times 45? 3330. Divide that by 30, and I get 111. So he can eat 111 of those things in 45 minutes. Number 24. Do you know what a Xerxes is? It's a small rodent that looks like a cross between a squirrel and a chipmunk. The ratio of tail to body length is 4 to 5. If the body of a Xerxes is 10 inches long, what's the tail? Well, 4 over 5 equals something over 10. 5 times something equals 40. So that would be 8. Everybody see how this stuff works? Number 26. Variation. Now you might have to go back to page 386 and read this, but here's what you need to put in your notes. Direct variation is y equals k times x. K stands for some constant. And why they call it K, because constant starts with a C, but hey, we're just following the book. Y equals K times X. That's called direct variation. And while we're here, inverse variation is y equals k over x. And we'll come to that one in a little bit. But you need to have both of these in your notes so you can remember, because you won't have it in your head, so you'll have the formula with you when you take the test. And here's what 26 says. Interest is directly proportional to amount of money. So, for A, write an equation of variation. I equals K times AM, or A. That's what they want. Direct proportion, direct variation, means you put that K for that constant in there. So B says, if $480 produced $26 in interest, then what's K? Well, $26.40 equals K times 480. See what I put the 480 here? And I put the 2640 over here. And then I just divide by 480, and K equals 2640 divided by 480. And what's 26.4 divided by 480? 0.055. So that's the constant of variation. What they mean is, well, watch what it says next for C. How much annual interest would you receive if you had $750? Now that I know what K is, I put this number in place of K, and I put 750 out here, and I can find the interest. See, once you find K, then for the next problem, you put that number in place of K. So now I have 0.055 times 750 equals $41.25. That's the interest. You follow what's going on? Number 28. Distance varies directly. As soon as they say that, watch what I do. Oh, as the square of the speed. So here's distance varies directly equals K times S squared. Everybody see where I'm getting my numbers, my letters? K is always that unknown constant of variation. And when it says varies directly, then that's when I write, maybe put this in red. When it says varies directly, that's when I put equals K times something. And then distance D and square of the speed S. So 28, I've done A, that's A. B says if the stopping distance is 54 when you're going 30 miles per hour, what's K? Well, 54 equals K times 30 squared. 30 squared is 900, so K would be 54 divided by 900. What's 54 divided by 900? 0.06. And there's my constant of variation. So now that I know that, watch what's going to happen for C. If the, where'd it go? When the stopping distance, what's the stopping distance? So now they want to know the stopping distance. for a car going 60 miles per hour. So I put 0.06 in for K, and 60 squared is 3,600. And what's 3,600 times 0.06? 216 feet. 216 feet. How many feet in a yard?
3.
3. So divide 3 into that. That's 72 yards. When you're going 60 miles an hour, it takes 3/4 of the length of a football field for your car to stop. Think about that when you're tailgating somebody on the interstate going 70 miles an hour. You know what you are? You're an accident looking for a place to happen. That's what you are. Okay, enough of that. Let's move on. We got problems to work. Number 30. To remain popular, the number of new songs a rock band needs to produce each year is inversely proportional. So that's also on page 388. Inverse variation is y equals k over x. So the number of new songs S varies inversely. So I put S equals k over y. Everybody follow what's going on? Because it said varies inversely, that's why I wrote this right here. Actually, varies inversely is why I wrote this right here. And then this is the y, and this is the s. I have a variable here, my constant of variation, and the other variable here. And because it says varies inversely, I put k over something instead of k divided by something instead of k times something. So 30a said, write an equation of variation. I just did that. S equals k over y. B, if after 3 years, that's years here, the band needs 50 new songs, how many songs will they need after 5 years? Now, they just mixed two problems together. If you need 50 songs after 3 years, how many songs after 5 years? See, this is 50 equals k over 3. This is how many songs equals k over 5. And I can't work this problem until I know what k is. I use this problem to find k. Times 3 times 3. So k is 150. So now I come down here, and in place of k, I put 150. So now I have S equals 150 over 5. So that means they have to have, after 5 years in the business, 30 new songs. So you see, sometimes they're going to ask a question that, without telling you, they're not going to say find the constant of variation, but you have to find the constant to work to answer the question. So here's A, here's B, no, here's B. They skipped this step, so you have to say, no, they have A and they have B, but in my mind, I'm doing A, B, and C. You follow what's going on? I'm going to make it a 3-step process. I'm going to set up the variation equation. I'm going to find the constant of variation. Then I'm going to use what I find as the constant of variation to solve the problem. let's go down to 32. Boyle's law says if temperature is held constant, then the pressure, P, varies inversely as the volume. So A would be P equals K over V because it varies inversely. If P is 24 when V is 18, what is P when V is 12? You see how quick they just jump? So it's like, well, I have to do B first before I can answer the question. So I go, and B is find K. So I go 24 equals K over 18. So K is 432. Everybody follow that? So now I found K. Now I come down here. What's P when V is 12? So see, that's P equals K over 12. But K is 432. So I take 432 and divide it by 12, and I get P is 36. See what's going on? You see the process? They tell me what kind of variation I have. Then I use that information. Then they give me some information that I use to find K. Then I use my answer for the constant to find the last question they ask. And they do that all the time. Number 34. The weight of an object varies inversely. Weight varies inversely as the square of the distance. So here's my formula. W equals K over D squared. Everybody see where I get that? It said varies inversely. So that's the way I write it. Then it says, for number 34, an astronaut weighs 121 pounds, that's weight, on the surface of the Earth. If the radius of the Earth is 3960 miles, find the value of K. So I take 3960 and square it, and take it times 121, and K is what? 1,897,473,600. Now, I don't know if your little calculator goes that far, but if it doesn't, then just call it 1897.28 million. And then you come down here. What will she weigh? C. What are we doing here? 34. C. What will this astronaut weigh when she is 880 miles above the surface of the Earth? That's 3960 on the Earth, plus add those two together and you get 4840. So W equals K over 4840 squared, and K was what? 1897.28 million. So you end up squaring this number and you get 23 million. So that's 23.425 million. So I divide 1897.28 by 23.4256 and I get about 81 pounds. Number 36. The price of oil varies inversely with the supply. So when it says varies inversely, that's what I write. Write an equation of variation. I just did, so that's A. What is K? In the year 2000, the price of 1 barrel of oil was $26, and OPEC produced 24 million barrels. So what would K be? 24 times 26 million, or 624 million. So that's K. So now I come down here to C. In 2005, OPEC plans to increase production to 28 million. That's the P. What would be the price? 36. Price with supply. Price with supply. What would the price be if the supply is 28 million barrels? Yeah, so 624 million divided by 28 million is $22.29 a barrel. Number 38, the number of miles you can drive your car is directly proportional. So when it says directly proportional, that means I go M equals K times G. Miles driven equals the constant times the gallons of gas I have. And then it says, so that's A. So B, the greatest distance driven without refueling on a single fill in a standard vehicle is 1,691.6 miles. So I went this many miles with 38.2 gallons of gas. So what would K be? 1691 divided by 38. So K comes out to be 44.3. So that's my constant of variation, which means this car that they just described here gets 44.3 miles to the gallon. Well, my car gets about 40 miles to the gallon, but it sure won't go 1,600 miles. Yeah, because I don't have a 38-gallon fuel tank. Oh, I go to the pump, the little light comes on, says low on fuel, fill up. I put the thing in there and pull the trigger, and it shuts off after 10 gallons. This guy had a tank that would hold 38 gallons. If you have a car that holds 38 gallons, it doesn't get 40 miles to the gallon. It probably only gets about 20. If you have a car with a tank that holds 60 gallons, then you probably only get about 10 miles to the gallon. The guys who build cars kind of build them all to go the same distance on a tank of gas. So what the guy who's getting 10 miles to the gallon has to have a 4 times bigger tank. So that means when I buy 10 gallons for $25, he has to buy 40 gallons for $100 to drive the same distance. I don't know if that means anything to you, but when I see somebody driving down the road pulling a travel trailer behind his great big pickup, I say, Nina, we ought to get one of those. And she goes, and what does it cost per mile to pull that thing down the road? And here's what I figured out, that if I decided to see America with a travel trailer, so I wouldn't have to pay $100 a night to stay in a comfort inn where my wife likes to feel comfortable, it'll cost me about that same $100 a day to pull that camper down the road, as opposed to driving my little Honda that gets 40 miles to the gallon and lets my wife stay at Comfort Inn. The only problem is sometimes you can't find one, but she doesn't care. Just keep driving till we find one, Tom. I do not like the idea of staying in a camper. It's my fault. I took her camping to Colorado when she was pregnant. That was not smart, guys. You know, guys, do your homework. Don't just go out and wing it when you get married. Ask some older people who've been married a while if some of your ideas are good ideas. And if they say that probably isn't a good idea, don't do it. Just don't do it. You'll pay the rest of your life. Number 40. What does number 40 say? Have you called on a radio contest lately? According to Don Burley in Kansas City, the listener response to a radio calling contest is directly proportional, varies directly, to the size of the prize. So the calls vary directly as the size of the prize. And it says here, A, if 40 listeners call when the prize is $100, then I'm going, so K is 0.04. Divide 40 by 100. So now, look what it says next. How many calls would you expect when the prize is $5,000? And I put, in place of K, I put 0.04 or 0.4. Is that right? 40 divided by 100. Yep, 0.4. So I take 0.4 and it's like, whoa, I'm going to get 2,000 callers. Yep, when the prize is $5,000. Number 44. Oh, this is a good one. Number 44 says, according to George Flick, the ship surgeon of the SS Constitution, the number of hours your life is shortened by smoking cigarettes varies jointly. Now, that's an interesting phrase, isn't it? Joint, smoking. Oh, that's a sad joke, isn't it? Okay, varies jointly, as in, jointly means there's two of them. In and T plus 10. That's what jointly means. There's two variables. They just don't. Back there, they just don't care. Okay, so H would be the hours that your life is shortened, is K times, that's varies, K times these two things multiplied. And means you multiply. So it says if your life is shortened 25 hours, if you smoke 100 cigarettes and it takes 5 minutes to smoke a cigarette, 5 plus 10, 5 for T, and 100 is in. So doing that, I find out that K is 0.016666. So now I come down here and say, okay, so what's H if this is K times, what's this guy smoking? 2 cigarettes, 2 packs a day. There's 20 in a pack, so 2 times 20 times 360 days a year times 15, 5 plus 10, the time it takes to smoke one of them. And you know what this guy just did? He just took 5 months off of his life. What's a pack of cigarette cost? Is it $5 now?
Way more. $7.15.
$7 for a pack of cigarettes. And he smokes 2 a day. He's spending $14 a day on cigarettes. Can you imagine what he could do if he quit smoking? 14 times 30. The poor guy's spending $420 a month on cigarettes. Man, just save that every month during 9 months of the winter, and I could take my wife on trips and stay at Comfort Inn long time in the summertime. I said to my wife one time, you realize how much money we save because we don't smoke and drink? And I have to tell you, I mean, I feel sorry for the guy on the road who can't find a job, but if he can stand there with a cigarette in his hand while he's holding out his can wanting money from people driving by, I'm thinking he's got money somewhere. And that smoking is going to kill him. Okay, enough of that. Number 47, is that what it is? Anthropologists use the cephalic index in the study of human races and groupings. This index is directly proportional. So when it says directly proportional, and it's directly proportional to width and inversely proportional to length. So watch what I do. I go C, that's this index, is K times W, the width, and divided by L, the length. See how I set it up? It's directly proportional to one and inversely proportional to the other. And then when it says 98 is the index, when the width is 15 and the length is 21, so I can find K. It doesn't tell me to, but I can find K, and K comes out to be 137.2. So now I can take the question they asked and go C equals 137.2 times, they give me 15 and 20. And so I replace K with 137.2, and I get the cephalic index is 103 for that, whatever it is, Cro-Magnon man, whose head was 20 centimeters long and 15 centimeters wide. Stop at 47. Wednesday, we do the chapter, the practice test for this chapter, and Friday we take the exam. And I better write that down. What did I say I'm going to do on Friday? I'm going to grade your papers, grade the exam, and be in class after baccalaureate. Is that what I said?
Are you going to be here over lunchtime?
So what,
Yes, during lunch.
in this room you said?
So after,
Are you going to be in this room?
yeah, in this room.
Are you going to post our grade online beforehand?
Will I be able to do that? I probably won't. Because I have a class after this one.
Yeah.
But when you start turning them in, I'll start grading them. So some of you who turn them in earlier could maybe take it right back and fix it then. You know, before class ends. That might help for some of you. And the ones who take the whole time to take the test, just talk to me and we'll make some arrangements. During lunch, be in the Langmaid room. All right.
Okay, so I have class at 12:30 on Friday. How long are you here until you go home on Friday?
Well, when do you get out of class?
I get out of class about 2 o'clock, and then I'm free the rest of the day.
So,
And I'll also be here Saturday, so I
Where-
could come Saturday morning.
where is your class at 2 o'clock?
It's in East End.
So where could I be?
But I could
Yeah.
come back over here. I could go right now.
Yeah, if I'm in here, then I could be helping people with the tablet. Okay?
Okay.
So at 2 p.m. Friday,
Yes, sir.
I'll also be here in the Langmaid room.
Okay.
Will that work for you?
Yes, sir. Thank you so much.
You're welcome. All right. All right. Who has a oh, let me turn this off. Who has a question?
Can you do number 37 from 6.4?